morning again, and becoming like a repeat moderator here for the day, and I'm happy to moderate this session. We got 20 minutes on the clock, so we're going to make again the best use of the time of the panelists and the audiences in here, with some walk away of something you learn from here, and hopefully will be also applicable in terms of networking, knowledge sharing, and practices, best practices. That being said, it's still before noontime, and it's good morning, everyone, and it's a pleasure to welcome you to this focus panel discussion on determining sufficient safety, qualifying or quantifying and countering potential risks through layers of protection analysis, LOPA. So that's the session. And I'll start probably a little bit of preface for this one so that we can engage in some meaningful discussion and sharing. So the idea of sufficient safety, there's such a thing, by the way, sufficient safety, isn't just a theoretical goal, it's a practical necessity in today's high-risk industrial environments. Regulatory expectations, of course, they all intensify, and our operational systems grow more complex. And LOPA provides a structural way to evaluate risks and ensure that protective barriers are not just in place, but also they're effective on a moment's notice. They can be invoked and delivered. So today I'm joined by two seasoned professionals who each bring deep experience in applying LOPA principles across the kingdom's major industrial sectors. Mr. Mohammad, Bashir, SIPCHEM, repeat from a panel earlier today, and Mr. Mohamed, Mesbah, SABIC. Welcome to this session. And let's begin with some maybe foundational, sort of like a teaser question on the foundational issues. So we want to maybe defining sufficient safety to begin with. So clarify maybe to the audience the core idea. And along those lines, maybe the question is, how do you define sufficient safety in high-risk industries, and what benchmarks or criteria do you use to determine when it has been achieved? So the definition and the benchmarks. You want to go first, Mr. Mohamed?
Thank you, Mr. Jamal. This is very critical and important question. It hits the heart of what we do in process safety. If we cannot answer this question, at which level we can say that safety is sufficient, this will end up with one of two things. Either we will handle risks with higher, handle activities with a higher risk that is not tolerable, or we will consume a lot of resources in order to reduce the risk to a level that is grossly disproportionate with the benefits. So let me give an example from our real life, away from the industry a little bit, and we will come later to the industry. I will talk about first the road safety. In Kingdom of Saudi Arabia, the kingdom targeted to reduce the fatal traffic incidents in Saudi Arabia by 2030 to 10-4. This equals 10 per 100,000 people, 10 fatalities per 100,000. Back to the past, in 2016, the fatality rate, there were recorded 9,031 incidents in 2016. This equals 28 fatalities per 100,000. So the current risk at that time was 28 per 100,000, and we need to reduce it to 10 or less than 10 per 100,000. How the government or kingdom behaved on this? Fortunately, in 2023, the fatality rate reduced to around 4,400 fatalities at that year, 2023. This equals 1.3 10 minus 4. So to reduce the risk from 2.8 10 minus 4, 28 fatalities per 100 to 13 fatalities per 100,000, the government put layers of protections, starting from enhancing dangerous routes, identifying the most dangerous routes and enhancing routes, provided requirements for vehicle inspections, cameras for speed, harsh penalties. This reduced the fatality rate to this extent. In addition to this, they reduced the time required for emergency response to be less than 10 minutes. So the ambulance can reach to the incident within 10 minutes, and this will reduce the fatality rate. Let us now mirror this to our industry. Our industry, our benchmark, ranging from 10 minus 4 to 10 minus 5. This is common in the industry, and to achieve this, we put multiple layers of protections. Let us take an example. A control valve failed, the pressure started to increase in a pressure vessel, the pressure vessel ruptured and led to single fatality. If we assume that the risk comes from the initiating event, the control valve failure that would lead to fatality directly, the risk will be too high. Nobody will accept the risk 10 minus 1, 10% probability of lethality. This is not acceptable number. So what we do, we put layers of protections to fill the gap between the target risk and the current risk. These layers of protections include, for example, alarms with human intervention. We put safety instrumented system. We put mechanical protections. These layers of protections can fill the gap and reduce the risk between the target, as we mentioned, to achievable risk reduction numbers.
Okay, thank you. Mr. Bashir, your take on the sufficient safety and also on the benchmarks at the SIPCHEM.
Okay, thank you. For sufficient safety, how we can define it, like considering the best industry practice, like how much risk we can reduce. And sufficient we define as the reduction should be as low as reasonably practical. And we can adopt a LOPA phenomena where we configure it with our corporate risk matrix, corporate strategic risk alignment, plus there are some benchmarking with if we are considering LOPA, and that is related to IEC 61511, and that is giving us a good benchmarking where we can see, for example, where we can see that requirement for single fatality, how many layer of protections required, and how effective those layer of protections are placed in the system. So to see the adequacy of those layer of protection, and what we are identifying during LOPA stage, that all IPLs are functioning, are available, are auditable, and those IPLs are effective when it is required to implement. And we need to remove all the commonalities from these IPLs. Like we should not be sometime in a very poor, I will not say poor, it's just wrong judgment adopted in LOPA study. They are considering even common cause failure in lot of IPLs. So that should be judgmented effectively, and then those common cause failure should be removed and more layer of protections should be added. That can bring it to a LOPA level or as low as it is possible, considering company risk appetite. So how will define company risk appetite? That is governed by the board of directors, what they are accepting, what they are mandating their company. Usually in industry, in UK, in the Middle East, we are going for single fatality once in a 100,000 year. That is normally accepted for individual risk. And coming to the second point, how we evolve in SIPCHEM for the LOPA study. We are following a practice that each risk assessment or each deviation of any controls, we are going for LOPA. And on a regular basis, if we have to bypass any interlock, or we need to remove, or we need to defer HSE critical equipment, then we'll go for LOPA study. And we'll see what is the residual risk based on the removal of that interlock or bypassing of that interlock. And for overall redo studies, after every redo or revalidation study, we are revalidating our LOPA, and that is mainly linked with update of any consequence. Maybe we are discovering new consequence, we are learning from some industry incident or similar industry incidents, or new recommendations are coming from licensors. Because most of the time, licensors are sharing their best practices in terms of safety, process safety. Like for example, they have at their site in China or Europe, they have one incident which was not discovered, and they are introducing new layer of protection. And these are being shared with all licensing companies, and then it is revalidated again. And those incidents are incorporated in the redo study, revalidation study, and they take part in our layer of protections. And sometimes we are over-exaggerating some scenarios. Like for example, some explosion scenario or some leak scenario, we have taken a single fatality or multiple fatality. But when it comes to cure stage, a quantitative risk analysis, and it proves that it is not going to more than LTI. So it was over-exaggerated scenario, more layer of protections was added, so it was expensive solution. So with this refinement, what can we do? We can remove some unnecessary layer of protection, and we can reduce the maintenance cost, keeping those in layer of protections or IPL healthy all the time. That is also a vulnerable cost for the company.
Okay, great. So I mean, when I think of SABIC or think of SIPCHEM and the other industries here in Saudi, I think of world-class industrial complexes that has standards, protocols, practices, and sometimes I mean, they lead the way also in the sectors on the world-class. Being also a national industry in Saudi, that's very important. So if to ask this one maybe, I want to know maybe at SABIC the evolution and the value of LOPA. If you can just like briefly, how did it evolve within SABIC or within SIPCHEM, the question to you next, and measurable maybe improvements so you can justify this evolved, but also brought in value and tangible results.
Fine. We started with very similar steps to SIPCHEM. Actually, LOPA started first with project. It was associated with HAZOP studies during engineering phase to identify the required safety integrity level for safety instrumented functions. So we utilized LOPA as a beginning as a cell assessment tool. And later we started utilizing LOPA more in high consequence scenarios. So if we have any scenarios that might result in fatality or more severe impact to the environment or the assets, we start utilizing LOPA as well. After that, we utilized LOPA in our day-to-day activity. If we need to take any safety integrity, safety critical element out of service for maintenance, for example, we have to revise the LOPA and check what is the, how far we deviated from our risk target. Are we still safe, or now we need more compensating measures in order to fill the gap and reduce the risk? So this is the last stage. Now we are in a phase of a challenging the adequacy and effectiveness of our independent protection layers. Are they really functional? Are they reliable, independent, auditable? This is our approach right now.
Okay, for SIPCHEM, what we do, we have, usually we are maintaining for SIS or Safety Instrumented System, mostly company maintaining it very well, doing the PM on the time, and adequacy is well adopted. But when it comes to our human layer of protection, it is lacking, and we haven't built up our procedure that we can consider our human layer of protection like operator response with the alarm to level of IPL. So that is one of the gap we identified in SIPCHEM, and how we can bridge that gap, what are the factors that we need to adopt in our operator training. We provided a refresher procedure and protocol that we need to revise the training for the operators, and we included the drills. We make those alarms as a safety critical alarms. So that is enhancing a layer of protection, which was just a alarm and operator response, and which was a weak layer of protection. That if we have follow all the checklist of human layer of protection as per LOPA guidelines from CCPS, then we can take a credit for these alarms. And another thing is that when we are assessing the layer of protections, and when it's come to any management of change for removing any interlock or adding any interlock, usually we are taking a benefit of doubt, like for example DCS. DCS is up to failure rate of once in 100 year or once in 1,000 years, some of new systems, and we can take 3 credits, or we can take 3 layer of protection if there is independent transmitter, final control elements are available. But there are some limitation as per LOPA guidelines, as per IEC 61508, 61511, and then maximum tangible credit can be taken only required by the procedure. It is 2. We cannot go more than failure frequency more than once in 100 year. So that refinement is also required, and we need to draw a very clear line that instead of taking those safeguards into consideration, we should be realistic, and we should be considering how much maximum safeguard we can take it. Like for example, for the PSV, as per standard, we are taking, if it is available with isolation and car seal or key lock system, we can take 2 IP, consider it as a 2 IPL. But if we have a PSV available, or 2 PSVs are lined up equally sized for the same scenario, for high pressure scenario, and both are lined up, we cannot go for 4 IPLs. It is equal to 3 IPLs. Okay. So this is how we need to carefully assess in LOPA scenarios while doing any management of change. And this is the gap we identified and addressed already.
Yeah, I mean, in applying protocols and standards and having a corporate strategy is paramount important. But sometimes also, maybe this is a challenge, and maybe you can briefly tell us, how do you maintain uniformity, consistency across different units, like, you know, multiple teams, facilities, maybe business units, and so on and so forth. How do you do that uniformity and consistency across different teams?
Actually, it starts with guidance, unified guidance that govern all units inside the company. Same risk target, no different risk target in different locations, and training and awareness, how to utilize this guidance, how to utilize the independent protection layers, at which level we can give credit for any independent protection layer, what is the criteria to accept or to reject. This is a second point in addition to the awareness. And lastly, through audits, periodic checks, to assure that it is unified, there is no deviation between plans. And finally, actions and data outcome from these studies can be incorporated in one platform so that we can check if there is any discrepancy, we can fix it.
Thank you.
I second Mesbah point on this one. The assurance role is the main. Like if we have all the assurance engineers, like process safety engineers or reliability engineers related to control system, if they are well updated with the requirements of LOPA guidelines and they are well applying to all the affiliates, all the companies or all the facilities, then I believe we can have a good benchmarking that the applicability of LOPA rules will be aligned across all the sites. So this is why assurance role of process safety is very vital and very much mandatory. This plays a role for equal implementation.
So maybe in closing, we're a little bit over time in here, but if we talked about the AI and the digital tools and using it, can you share a little bit of maybe instances where LOPA findings led to some maybe design changes using those AI tools, or maybe reducing maybe process modification, reduction, and things like that. And I mean, nowadays, I mean, everything that you have, you can have the physical layer, and you can have the digital twin of that. And LOPA, like anything else, you could show that in using LOPA practices, assessment tools, different tools in the market, how does that really incorporate all of these new digital tools for the value added that they bring in? Digital twins is maybe at the heart of it in a way.
Yeah, actually, whatever the sophisticated tools or AI tools will add it will not discredit the availability of layer of protections. It is enhancing for the studies and having a real-time data, because especially these digital tools, AI tools, and if we are going with the industry 4.0, that will have a realistic data for that particular plant or that particular facility. So that will be more realistic either rather than using OGP data or company own set criteria. So in this process, I believe digital tools are very mandatory, and if they are linked to your LOPA program, if we are doing LOPA through Exida, through Meridium, or through other tools, PHA Leader, and how we can integrate it with our failure frequency. So that is a real-time game changer, I believe, that's going to happen. Currently, we are moving towards it, but I think we didn't achieve to that point.
Regarding us, till the moment we haven't adopted the AI, but I can imagine the impact that it could add to our layers of protections. Actually, we review our LOPAs on demand when we need it, or periodically during revalidation or redo studies every couple of years. I am imagining that with AI tool, we will have a real time and monitoring for our IPLs, so that any anomaly that could happen in one of the IPLs, we will know immediately, and there will be some quick and on-spot solutions to support us to reduce the risk to the acceptable. LOPA alone, layers of protections without checking them and following up and assuring they achieve the required function from them, they will degrade. I believe that using previous failure histories and machine learning, we can identify and predict the possible failures and take proactive actions in order to assure that the safety is within the sufficient level.
Great. Well, with this, probably we want to bring it to a closure, but AI is important definitely in every aspect, everything. LOPA is no exception. And if I look at things that they're in real life, things change with space, so there's spatial variation, but this change also at time. One snapshot in time, it could be different. So things are varying spatially and temporally at the same time. That makes it doubly, I guess, in terms of modeling, but with the advent of computers and the way that software tools and things like that, they're evolving. They're making the computational and the different scenarios to be done really virtually to start with. And even you can have layers, virtual reality, augmented reality, play different scenarios and make the cases, and in developing and anticipating problems and combating these problems to the point that I think it makes the system in total, the whole ecosystem, to be more efficient. With this, I want to bring this one to a conclusion, and I want to thank our panelists from SABIC, Mohammad, and from SIPCHEM, Mohamed, the two of you. Thank you so much for your insights, and thank you for the audiences. And this brings us to a conclusion of this session. Thank you again.